NASA is advancing science and
When
technology.
the NASA
with
moon
the first
rocket
flight
Artemis
of the
1
Space
launches,
Launch System.
there will be stowaways on board. Perched in a circle inside the rocket are 10 CubeSats. They will hitch a ride into space and then be flung off to conduct science or observation missions. CubeSats are the size of a large shoebox or a small suitcase. Many carry solar panels for power and propellant to get them to a specific spot or orbit. Several of the stowaways have a moon mission, just like the rocket they're riding. One is called Lunar Ice Cube. It'll be looking for signs of ice, which in the future could be used by astronauts to drink and make fuel on the moon.
And the science mission for Lunar Ice Cube is to prospect for water ice. Specifically, Lunar Ice Cube is looking for water ice in liquid and vapor forms and other lunar volatiles we have the sensitivity to see. But specifically looking at the distribution of water ice from the mid-latitudes to the PSRs, the permanently shadowed regions, where it tends to collect. So Lunar Ice Cube is actually a science mission and a tech demo mission. There are a number of really innovative, unusual technologies that are sort of enabling technologies that allow us to do this kind of science with small platforms.
Another CubeSat has been developed by the Japanese space agency JAXA. It will land on the moon. Actually, it's called a semi-hard landing because the little spacecraft will use an airbag to cushion its landing. No soft touchdown here. JAXA is trying to prove that spacecraft can survive such a landing on the lunar surface. JAXA's Omotenashi spacecraft will carry some technology that came out of the Fukushima nuclear disaster as well, monitoring radiation, one of the enemies of humans in space.
We need to monitor the radiation environment, even for the school children. So the Japanese Institute developed a very small portable radiation monitor for the children. So after that, JAXA started the research to use for that small monitor to the astronauts, or such kind of small sensors can boost every spacecraft because it is a very low power consumption and a very small size. So our mission is test for such a tiny small sensors can detect the radiation environment precisely or not. That is another challenge. But if possible, we would like to spread such kind of a small sensor to every spacecraft to the moon or Mars or some destination.
NASA admits these little stowaways are high-risk missions. They may not work, but these CubeSats are relatively inexpensive, and the payoff could be huge. I'm David Curley. That's Full Throttle.